standard form of a quadratic homework. Each question in the first section here asks us to do 5 things. Graph the function showing all lattice points that it passes through clearly, state the vertex, state the axis of symmetry as an x equals equation, rewrite the equation in standard form, and state the y-intercept. So for number 1, I can see that my a, h, and k values are a is 1, h is -1, make sure to take the opposite there, and k is -3. So this is in vertex form, made it very easy to see these points. It also makes it very easy to graph. My vertex is at -1, -3. I go over -1, I go down to -3, I put a point. Now because the a value is 1, the walls of this parabola are just going to mirror our parent function. From the vertex, they're just going to go up 1, and then up 4, counting from the vertex, and then up 9, but I'd be going off the graph. And let's just make that symmetrical. All right, connect up our points. All right, state the vertex. The vertex is at -1, -3. Let's see, state the axis of symmetry. I'm going to abbreviate that AOS. Now the axis of symmetry would be, how can I draw a line in here to make this symmetrical? Well, I'd have to make that line perfectly vertical right through the vertex. And how do we write the equation of vertical lines? We write them as x equals equation. This equation here is x equals -1. All right, rewrite the equation in standard form. This is where we have to FOIL. So I've got x plus 1 squared minus 3. When I expand this out, it becomes x plus 1 times x plus 1 minus 3. That gives me an x squared plus x plus 1 minus 3 for a final standard form of y equals x squared plus 2x minus 2. All right, and that would mean the y-intercept is -2, which we can clearly see there, also at the end of this equation. Y-intercept is, we'll just say -2. We'll just say equals -2. All right, on to our next one. Our vertex is right at the h comma k point of -3 comma 4. Let's plot that now. All right, now our a value is -1, so as I go to draw in the sides of this parabola, I can take the intervals from my parent function of 1, 4, and 9, and just multiply them by my a value of -1. This gets me -1, -4, and -9. So from the vertex, if I want to go 1 over, I got to go 1 down. If I want to go 2 over, I have to go 4 down. Let's make that symmetrical. Connect those up. All right, our axis of symmetry is a vertical line that would go through the vertex. So we'll say the axis of symmetry is x equals -3. Now it's time to convert it to standard form. So I'll rewrite it again down here, negative x plus 3 squared plus 4. This becomes negative x plus 3 times x plus 3 plus 4. I should multiply my first terms. I get x squared. That's the x times the x. My outside terms give me a 3x. My inside terms give me another 3x. And my last terms give me a 9. We still have this plus 4 in the end. We still have a negative that needs to be distributed. Let's see if I can't zoom this in a little bit. Just a little bit more room. All right, so this here becomes negative x squared minus 6x minus 9 plus 4 plus 4, we'll fit it in there, negative x squared minus 6x minus 5. That's our standard form. That should be y equals that for the standard form, and our y-intercept is at negative 5. All right, so that's off this graph, but you can imagine if this line kept going, it would intersect somewhere down here. And we found the value of negative 5. That makes a lot of sense. All right, number 3. Vertex at 4, negative 2. Let's put a point at 4, negative 2. To get our next points, I'm going to take my pattern 1, 4, 9 that comes from our parent function, multiply each of those values by negative 2 to get negative 2, negative 8, negative 18. And now these are the intervals that I need to go down by as I move away from the vertex. I go 1 over from the vertex, I've got to move 2 down. If I move 2 over from the vertex, I have to move 8 down. That's all the points we can fit on this one. Connect them up with a parabola. Draw it going off the graph down towards negative infinity. All right, let's convert this one. Oh, real quick, axis of symmetry. It's going to be x equals 4. Let's convert this to standard form. Show the work for that down here. So y equals negative 2, x minus 4, x minus 4, minus 2, y equals negative 2. We FOIL this. Our first terms make an x squared. Our outside terms get a minus 4x. Our inside terms get us a negative 4x, and our last terms get us a plus 16. Distribute that, well, okay, I'll combine like terms in one step here, and then I'll distribute it to seconds since we've got a little more space. I distribute that negative 2 to negative 2x squared plus 16x minus 32 minus 2. And that gets us final standard form of y equals negative 2x squared plus 16x minus 34. Just double check. No, I think that makes sense to me. So our y-intercept is negative 3. The y-intercept is negative 34. It just comes from the c value in standard form. All right, number 4. Moving right along. Our vertex number 4 is going to be at negative 4, negative 4. Let's put a point right there. To get our next points, we can take our pattern 1, 4, 9 and double each value because our a value is 2. So I multiply these by 2, I get 2, 8, 18. So from our vertex, if I want to go 1 unit to the right or left, I've got to go 2 up. If I go 2 units over, I go 8 up. And now we're off the graph. Probably noticed a pattern that we generally go off the graph within the first 2 or 3 points away from the vertex. That's because these grow exponentially. so they go off the graph pretty quickly. That's why we don't have to memorize a lot of our squared values. Just 1, 4, and 9 generally is enough to get the shape of our parabola. All right, axis of symmetry is at x equals -4. Let's copy this down so we can convert it to standard form. Y equals 2 times x plus 4 times x plus 4. Y equals 2 times x squared plus 4x plus 4x plus 16 after I FOIL. Let's distribute that 2x squared. These would combine to be an 8x, and then it gets multiplied by 2. So that gives us a 16x plus 32 minus 4. Y equals 2x squared plus 16x plus 28. Y-intercept equals 28. Okay, a couple more. Vertex at 4, -4. Let's put that right there. 1, 4, and 9 when multiplied by my a values become 0.5, 2, and 4.5. 0.5, 2, 4.5. There's our parabola. Really clear this point there. Let's see. Axis of symmetry. X equals 4. Converted to standard form. One half x minus 4, x minus 4, minus 4, 1 half x squared minus 4x minus 4x plus 16 minus 4, 1 half times x squared minus 8x 16 minus 4, 1 half x squared minus 4x plus 8 minus 4. After I distribute that 1 half, gives us a final equation of y equals 1 half x squared minus 4x plus 4. Notice that the a value in vertex form, 1 half, is the same as the a value in standard form, which is 1 half. Last thing to do is we say this is our y-intercept at 4, and that makes sense. That looks like about where this would cross if this parabola kept going off to the left. All right, last one of this type. Our vertex is at 2, 4. Put a point at 2, 4. 1, 4, 9 becomes -1, -4, -9. Down 1, down 4. Make it symmetrical. Our axis of symmetry is going to be x equals 2. That'll create a vertical line at 2. And let's set up to convert this to standard form. -x minus 2 Squared plus 4. Expand that exponent. X minus 2 times x minus 2. X squared minus 2x minus 2x plus 4. Keep track of your positives and negatives. When doing this, this will become negative x minus 4x plus 4, another plus 4. We distribute that negative. We get negative x squared minus or plus 4x minus 4 plus 4, and then that minus 4 and that plus 4 are going to cancel out, and we're going to get y equals negative x squared plus 4x. The y-intercept in this case is 0. We can actually see that on the graph too. Right there, where we cross the y-axis is at 0, so this makes sense. All right, so I left you with a system to solve algebraically. You can do this however you want, as long as you use either substitution or elimination. I'm going to use elimination. It looks like I can eliminate my s variable without too much trouble, so I'll do that now. Copying down my second equation. I'm going to multiply this one by 6 right below it. This is going to get my cancel out, so 6r s plus 30t equals 30. Add these together. And 9r plus 33t equals 21. All right, then I'll use equations 1 and 3 because those will cancel out an s as well. These together we get 3r plus 8t equals 10. Now I've got a system with two equations that we call these our manufactured equations and two variables. Looks like I can continue to do elimination by taking this one and multiplying it by negative 3 and writing it below this one. That'll give me negative 9r minus 32t equals negative 30. My r terms cancel out. I get t is equal to negative 9. Plug that back in. I'll just plug it into this equation here. Three r just double checking my work here. Let's see. By negative 3, okay. 3r plus 8 times negative 9 is 10. 3r minus 72 equals 10. Plus 72 plus 72. 3r equals 82. That's not divisible by 3. Let's take a look at what we're supposed to get here. 6, 4, negative 1. 6, 4, negative 1. Six, 4, negative 1. All right, let's just see. When you run into an issue, it's a good idea to just double check all of your steps. Generally, it's just copying down, missing a negative somewhere. Be adding and missing something. Oh yeah. I cannot multiply 8 by 3, apparently. It's not negative 32. Eight times negative 3 is negative 24. Okay, so now when I add these together, we get those cancel. 33 minus 24 is 9. T equals negative 1. Divide by 9, divide by 9. T equals negative 1. Plug that in. Right there, this can give us a much different answer. We get 3r minus 8 equals 10. Add 8, add 8. 3r equals 18. Divide by 3, divide by 3. R equals 6. And now plug those both into maybe just that very first equation. R plus S plus 5. T equals 5. That in for R. That in for T. We'll get 6 plus S plus 5 times negative 1 plus 5. 6 plus S minus 5 plus 5. Combine our like terms, we'll get 1 plus S equals 5. And we get that S equals 4. Then I like to put those in alphabetical order. So R comma S comma T can be equal to our final answer of 6 comma 4 comma negative 1, which I'm pretty sure that is what it was on this page. Here, 6, 4, negative 1. Good. All right. Well, that is that homework there. Stop by SOAR if you've got other questions.